Hello world and welcome to Julien's Tech Bites, a podcast where we will learn about a software-related topic, one byte at a time. And to do that, we'll get the help of two experts who will help us discover the basics together. Hi there. Thanks for being here. I just want to apologize in advance. The quality of the audio for this episode is a bit lower than I would have hoped for. We're all quarantined and we had to do the interview via Skype, so some of the speakers have a lower quality of microphone. So I hope it's not going to be a problem for you, and enjoy this episode. Bye! Welcome everyone to this new podcast. Today we're going to talk about Inmemory Datagrids. And for that I have two people with me today. On the one side we have David Follen. Hi David.
Hi, so I'm Dave Follen. I've been working in IT for like all my career, pretty much more than 20 years, lately in banking, and the last 4 or 5 years I've been working on applications that are using in-memory computing and in-memory Datagrids.
Okay. And next to that we also have Nikola Franco, and Nikola is working for Hazelcast. Hey Nikola.
Hi folks, how are you? I'm Nikola Franco. I've also worked for all my career in IT, also for nearly 20 years, but I was a consultant for a long time. So actually, I've done a lot of different industries. And since nearly close to 2 years, I've been a developer advocate. I started at Hazelcast 6 months ago, so I'm brand new in the world of in-memory Datagrids.
Okay, thanks. So the setup is a bit special today because we're all in our houses. We actually have speakers in 3 different countries right now, so you might hear it in the microphones. So this episode is interesting for me because I met Nikola last November in Ukraine, and that's where I learned about Hazelcast for the first time. And I learned about in-memory Datagrids. And to this day, I still know nothing about it. So the first thing is, can you explain us what it is?
In-memory Datagrid is a very big word for, let's say, distributed data structures. I assume most of you are Java developers. If not, bear with me. We have this hash map, and that's in general what people want to use when they think about the cache. They put entries in that, they throw some stuff, and then they get it by key. In-memory Datagrid tries to keep the same concept, but by distributing it over the network in different nodes. So the words are very simple, but the underlying implementation is really, really hard to get.
Okay. Do you want to add something, David?
Yeah, and the important part, indeed, it's in memory. So we're not talking about getting data from a disk. We want to play with everything in the heap or potentially outside the Java memory stack, but it's everything is in RAM. So the important part here is that if you shut down the node somehow, you have to think about what happens to the data. It's much faster in terms of access, but then you have different constraints that come up. And I guess we'll talk about the different constraints.
So we're, just for me to be sure, we're talking about RAM, right? So not your typical computers.
Yes and no. So actually, yes, from a legacy point of view, it's RAM. But now there are certain technologies that bridge the gap between simple RAM and the disk, such as Intel Optane. So let's, for the sake of the argument, keep it simple, let's say RAM. But if people who listen to this podcast want to dig further, it's not so clear cut.
Okay, thanks. Okay, so we talked about memory. I'm wondering, why would I want to put all my data in the memory? Is there? I guess that requires specific use cases. Can you expand a bit more about that? I've never met a use case that needed that so far. So.
Okay, so the idea is that you want to have the data in memory because you don't want to have to fetch it from a distant system. For instance, a typical use case that we want to have is the fraud detection in cards, in transaction processing. Everything where you need very quick access to data and that you don't want to wait. Where the access is the time that you spend getting the data has to be very short. We use often the fraud detection as an example, but in banking you have other different cases. For instance, we can use it to have the old. In our case, we use it to copy the data that we have in old system, in mainframe system. We put this data in memory. The idea is here, we don't want the mainframe system. They were designed to run with patches, a lot of patches, and they're not adapted to the new world where we have a lot of concurrent access. Before, when you went to the bank, you asked to do the changes of your, let's say, your address and stuff like that. It was done at night for patches at night. Now it has to be done. You expect it to be done automatically, very fast, and the mainframes, they're not made for this paradigm. So in what we put is we load the data in the mainframe in memory so that we can shield the mainframe from this constant concurrent access.
Okay.
So it's all in memory, and it's much faster, and then we protect the mainframe behind the scene.
Do you want to add something, Nikola?
Yeah, it works. It works for any, let's say, disk-based data storage. It can be mainframe, but it can be also regular NoSQL data stores or NoSQL data stores. I mean, the fact that you put the data in memory, the RAM access or the disk access, even if you use SSDs, have order of magnitudes of difference. So the trade-off here is resiliency, but it's also be very, very fast. So you want to be as fast as possible, and the trade-off is you accept to have data that might not be as fresh as you would have got it from the data storage in the first place.
I understand. All right. So that leads me to wonder, how do I work with it? Like if I have Datagrid, I guess I still have an application, a web application or something in the front end, and I still want to be able to use that data. How do I interact with it? Does it look like an API from the outside? Does it look like a database? How do I interact with the Datagrid?
Yeah, the in-memory Datagrid world has still no standard. So in the SQL world, we have standards, and then you have different implementation. They might differ a bit, but if you rely on the standard, you can normally, at least theoretically, migrate from one RDBMS to another without issue. The in-memory Datagrid has no such standards. So in general, every provider has its own API. Like at Hazelcast, we have an API. If we go to another vendor, it will probably have another API that might look similar, but might not be mapping one-to-one. Also, the biggest difference, you mentioned the database. We must be very careful using that word because it's a loaded term. For most people, database still means SQL database. And again, some vendors provide a SQL interface. We are in the process of implementing one. Some vendors do not. So it must be very careful with database. We must say what we are talking about. In general, most in-memory Datagrids, as I mentioned previously, they implement data structures. So the most well-known is the map. You put an entity under a key, then you get it. When you do the same in a SQL database, in general, you have relationships, and you have these super fancy ORM, or if you are using .NET, you have this entity framework that maps the world of the object to the worlds of SQL and back and forth. In in-memory Datagrid, it's much simpler. It's just key value. So relationships you must handle yourself.
Okay, understood.
That's the biggest difference.
I've heard about that for the past, like, I think I've heard about it for the first time a year ago or something. Datagrids, in-memory Datagrids. I've heard the term a few times. Like, is it me being biased now, or has the usage grown the past few years? And maybe why? Do you have some insight, maybe, David?
Well, we started working on it, let's say a few years ago. I think it was 2016. We see a growth. I see around different, more and more people using it, looking for it. I see it because in my position, I also sometimes need to recruit people for the project. And I'm looking for people that have at least ideas about in-memory Datagrids. So before, I didn't even try to search for people that knew about in-memory Datagrid because I didn't expect them to exist. But now, more and more, I see around that people have more and more experience. So for me, that's the view I have, and it tells me that the usage is growing. And especially now, the vendors are getting much more mature, so their solution is more and more ready for production and complex production systems. And that's also a very important aspect of having a technology that matures and grows. So yes, I see a growth, and I see, especially now, that more and more we want speed, we want distribution. That's I think the important part of in-memory Datagrid is this notion of partition tolerance. We want distribution of the data on smaller server instead of having a huge, big machine. So horizontal scalability instead of vertical one. So this is the paradigm that is coming for every kind of application, and that's the in-memory Datagrid follow this paradigm, follow this notion of distribution and increase of speed. So indeed, I've seen the usage grow, and I think it's going to grow even more.
Do you want to add something, Nikola? You're at the heart of you know more about the vendor.
I think that David is right in that, we are seeing things that are getting more and more distributed. I think there is a conjunction of factors. So the first is that RAM is cheaper and cheaper. So basically, when the cost of the RAM is cheap, then the investment in the Datagrids is not that much compared to the benefits. Second, whether you like microservices or not, they made people think about distribution, whatever that means. And so, a lot more people are now thinking about, hey, I just don't have one server, but I have multiple servers that might be in different places. They need to communicate. And what should I do with the data? Where is the data located? Is it co-located on each node? Is it in one central place? And finally, I also think that the NoSQL movement also helped a lot in that regard, because before, data was in a SQL database. Most SQL database that I know, they are master slave, so the data is in one place, and you must go through the master nodes to access the data. But most NoSQL database, they are distributed by design. Huh? They follow the CAP Theorem and all that stuff. And I think they also made a lot of people think that, data shouldn't be or shouldn't need be in one single location, but can be distributed for faster access. So I think there are a lot of different factors that make the adoption of in-memory Datagrids grow over the years. And it's not going to stop.
I like what you're saying. It might be me making relations, but in the first episode we were talking about reactive. I'm also preparing a podcast about machine learning in the industry, and you always see this conjunction of the requirements of the public changing, or people being more demanding with the services, together with the price of hardware going down, and at the same time also products becoming more and more scalable. Like you can, your products tend to be worldwide available in the whole world now. I feel like this might be playing here as well. You just touched something, Nikola. I'd like you to come very quickly back on it because you mentioned something and I don't know. It might be worth introducing it. You mentioned the CAP Theorem. Can you just describe what it is quickly so that we all understand? Or not?
Yeah, the CAP Theorem was not theorized by me. No, it means that you choose 2 out of 3, and out of the 3, there is C for consistency, A for availability, and P for partition resistance. So basically, if you say that you run in a monolith, it's not distributed, you can have consistency and availability and everything is fine. But as soon as you start introducing networking and distributing data all over your nodes, then it might happen that the network breaks. And now starts the hard work because you need to choose whether you prefer your data to be consistent or to be available. For example, Hazelcast by default is available because a lot of use cases are around caching. So you want data in all cases, and you accept that it might not be the right data. But probably in banking, you will have other requirements, and so it's better not to have any data than to have wrong data. And recently, for example, we also were thinking about that, so we have added a dedicated CP subsystem. So you can choose by default you are AP, but if you have a requirement, you can start your Hazelcast. You can have a dedicated place in Hazelcast where you will be CP.
And by AP and CP, you mean consistent or focus on consistency?
Yeah,
or
like AP means available and partition resistance. Yeah. Or I don't like partition resistant because you will be partition anyway. I will say it would be partition friendly, or CP, which is consistent and partition friendly.
Okay. Well, that's a perfect bridge to the next, big part of the podcast, which is much more about the consideration and the challenges of in-memory Datagrids. So we just mentioned consistency of data. Do you want to add something, David, about consistency? I'm guessing this is a bigger focus in the banking, indeed.
Yes, indeed. So yes, for us, the consistency is often like the most important part. And this notion of eventual consistent, it's hard to make people change, especially in the banking system. People, they want everything to be perfect. And we also have regulation that we need the data, we need to prove the data is perfect at all time. But also people want to have it all the time. So they want availability and consistency. We need to have partition tolerance because we need to be able to distribute and to grow. So here at some point we have to tell our business, say, yeah, but unfortunately you can choose only one of them. But it's still possible to achieve some kind of consistency with high availability. And that's why that's what in-memory computing or in-memory data grid are trying to promise. You keep the consistency, but since it's in memory, you don't have the trip to the database or to the data store. Therefore, it's much more available than a pure data or remote data store. And then comes the interesting part when you start changing the model, when you start thinking differently with maps, is how do you design your data? And that's the biggest change in moving to in-memory data grid. As we said, as Nikola said before, we work mostly with maps. So it's you put data, you get data. And you don't have true links between, you can't do a select with saying where father is or where the account manager is, something like that, where you have a relationship between data store. Because the more you put a relation between maps, the more complex it gets. So here you work with different maps. Let's say you have a customer that has accounts, and on the accounts you have transactions. So I receive money, I send money. Here, having strong links between the maps would make it much more complex to handle in terms of performance. You will have to block all the maps, and you will end up having the same problems that you have when you have a database. So you have to change the way you design your model. For instance, when you design in a database with tables, you want to normalize your data because you want to have some optimization. Here, you don't think about normalizing. You don't have the same notion. You have a big object that you have in your data in your hash map. So instead, for instance, let's say I had to modelize a customer, you would potentially let's say in the database say, I have a table customer, I have a table address, I have, I don't know, a table country, something like that. You would have different tables. And you could, with a simple request, nice indexes, get the data. Here, you wouldn't do that. Because here it's okay. You can say, okay, I'm going to put a lot of data in memory, but my customer will have all the information I need. So I will have a customer object. So you define data object, Java objects or .NET, most of the frameworks, they provide the possibility to use different languages, but you provide an object that's complete, that's not denormalized, that's not normalized. It's a bit denormalized. So you have a customer object that has an address field, that in the address field you have a country, which is a country object. You don't have a reference with a country code to a different country and things like that. So here you put the data, you modelize your data differently than if it was in a database.
Okay. Does it mean that you also introduce duplication?
Yes.
Okay.
Yes, indeed. And indeed, it's not a problem to introduce duplication. It's possible to have it. It's a bit like your index in the end. Your index is kind of it's a map, or it's a way to it's another view. Your index is kind of an optimization of how to access pages in your table. And here, well, you kind of take care of that yourself, and that's a big difference. You don't have this notion of index in in-memory data grid. So if you want to access the same data with two different ways, then you might want to duplicate it, having two different caches to make sure that you can access it properly on the two different ways. If the two different ways to access it are totally different. So this is here, it's important that you have to get out of your SQL modelization, let's say, world and go back into a map. It's a very different.
I do have some experience with NoSQL, and a lot of what you're saying makes me think about, and I'm going to mention the names, but the Firebase is or the DynamoDB, where you do have a unique index, and if you want partitioning, you also have to be careful about how you're going to create this index. But it's more of it's made by the vendor, so there are techniques to go around it. It feels like you're more in control using in-memory data grids. So you generate or you create your indexes in the way you would.
You don't create indexes. You don't create indexes. You just organize the data so that it's easy to access. So in one way, you're more in control, but in another way, it's not been optimized by clever people. I mean, I'm not saying that I'm clever or not, but the people who design the system, they spend time reading about indexes and they have tons of theories and stuff like that that's been proven. So they are very, very good at improving the access to the data. So what you gain in control, you potentially lose in expertise if you're not good enough. And that's very important because it's a new way of thinking. And there's still a lot to discover in terms of optimizing how you distribute your data in your different caches.
Do you want to add something, Nikola?
Yeah, so you make a good parallel, I think. Like if you are using MongoDB, for example, it's exactly like that. It's document-oriented database, and it looks a lot like the in-memory data grids. You are always already thinking about distribution of data. So that's great. But on the opposite, you must be very, very careful because in in-memory data grid, we are talking about derived data, not source of truth. So for me, that's the main difference. If you are using MongoDB, you are still using this data store as your source of truth. Whereas indices and in-memory data grids, they are derived data. So basically, it should be at least easy to recreate the data in the in-memory data grid from your main data storage. So on one side you are close to the truth, on one side you are completely opposite. So it's a new world. You must change your mindset. And yes, if you have been using NoSQL document-oriented database, it's a good thing. But still, on the other side, it's derived data. So it's ephemeral, yes.
Okay. So since we're talking about challenges and considerations, is there anything else that you want to mention? I think during the preparations, we talked about computing in memory. Do you want to say more about that? Because for me, that was something totally new. Maybe David, you can introduce, because I think you have more experience there.
Yes, this is an interest, and for me, that's very the where we really get a lot from in-memory data grid. The idea here is that we move away from having a client that needs to calculate. Let's say we need to calculate the average age of our customers, for instance, a simple stuff. So one thing, and we have a complex data model. So one thing we could do is from a client, get the data one by one or by batches and calculate all the data from the client. So you would potentially move all the data that's in the data store to your client and then do the calculation. Here, there's a lot of transfer on the network. If you could also use a notion of a stored procedure. So you have a stored procedure in your database, and then you call the stored procedure that's going to do the calculation locally. So here there's no transfer of data. Everything is done within the DBMS, and then you get the result as a response. Here, the thing with computing, the in-memory computing, is that you send a piece of code to the different nodes of your cluster, and this piece of code will be executed on the different nodes. And the good thing is that this piece of code will use data which is available in memory. And then once the piece of code has done the calculation, it returns the result. And then on the client, you gather all the results, but only the result, and then you do the combination of those results. So for instance, you would send to each node of your cluster, give me the average age of all the customers that are on your node, in your memory space, and you send that to the 5 different nodes. And then you get the sum, the number of customers, the sum of the age, and on the client, you just do the calculation on those small piece of data. So in terms of processing, it's much, much faster. You don't gather data. You don't transfer tons of data. You just transfer the result. And that's very, very, very useful and very important in terms of time spent to do complex calculation.
Okay. I see you dying to say something more, Nikola.
Oh, I mean, David has been doing distributed system for a long time. And that's funny because even then we make some assumptions. Like it's not because you get the average on each node that you can afterwards compute the average locally. That's really very symptomatic because some nodes might have 10 entities and some other node might have 200 entities. So you must really completely think differently. No, you must get from every node the sum of whatever and the number of entities, and only then you can do the computation. So I was not dying, but I mean, it's really a paradigm shift that even experienced people like David must do, because it's really easy to make this mistake. Also, the fact that, yes, people who design a SQL database are very smart, are very good. And now if you want more control, it's like everything. With great power comes great responsibility, meaning that now you must think about all those hard, complex stuff yourself. And if you start reading about distributed system, what can go wrong? You are there are a lot of issues that now your application must take care of. it's always funny when I see people in the microservices world saying, hey, we don't need transaction, we do compensation, and it's easy. No, it's not. It's not that easy, and you must account for the system being distributed. So yeah, that's what I just wanted to add.
So we did talk about, and that's really me not knowing where I'm going. So you did mention that there was a primary data store somewhere. We also mentioned that we would put data in memory to have a faster access, maybe at the loss of consistency or something else. But we made a trade-off there. How is the data being transferred to the memory data grid? Do we define the how to call that, the view, I would name it, or how do we define the schema, and then the system takes care of it itself when data comes in the system? I'm not expecting me to be able to do a put in there.
It depends.
Okay.
There are many different ways. So yes, you can do put and gets. I assume that most vendors allow put and gets because that's the most basic operation. But depending on some integration, you can have also like automatic population of the cache. For example, taking the example of the Hazel costs, we have the second level cache of Hibernate, meaning that as soon as you start configuring Hibernate with Hazel costs, and you interact with Hibernate, either directly or through GPA, then you don't need to take care of anything. Your second level cache will be populated anyway. Also, I mentioned previously that this is derived data, and you shouldn't be you shouldn't rely so much on it. But sometimes you want your cache to be up very, very fast. So if your cache has previously been populated, then it might be easier. And again, it's vendor specific to just dump it on disk and reread it from the disk and not from your primary data store. So it really depends. It's very implementation dependent, and probably depending on for other products, there might be other ways.
And I heard you mention JPA and Hibernate. Does it mean that I don't have to let go of my usual tool? Like I do have to do the paradigm shift that you mentioned, but I'm still able to use my JPA that I really like and I'm used to? Or
yeah, in this regard, yes, you can. And depending on how you configure it, you might be using a cache that is distributed or a cache that is only on one node. Again, it's a trade-off, meaning distributed cache, you will need to synchronize it over all the nodes, which you might not want. But then and then afterwards you need to think whether you want it to be available or you want to be consistent. So is it okay if one of the nodes has not the exact same version of the entity as the other one?
Available or consistent is going to be the motto of the day.
And yeah, it's always the same problem. Yeah. So that the kind of questions that come from distributed system. You must always question, what do I want? Like in the standard SQL world, we've got transaction, like data is always consistent, everything is fine. Well, everything is not that fine, but we pretend that everything is fine. But now you open the Pandora's box and come a lot of questions. And you need always to ask, what do I prefer? What do I need? What's my requirement? And then design accordingly. So it's much harder.
All right. And what happens when the cache is full? Like, what happens? There must be, what happens when something unexpected happens?
I like to take the image of what would you do if you implemented the cache yourself? In general, everybody has implemented one's cache. And in general, you use a map. But the problem is that the map is unbounded. So basically, it can grow unbounded. And at some point, you will have your friend the out-of-memory error. So production-ready caches, they have a limit. And when this limit is hit, you have different strategies to like evict all entities from the cache so that you are kept at this limit. So there are the least recently used, there are the most frequently used. There are like different ways to look at your data to consider what is the most useful data to keep in the cache. And then you have also another way to limit is basically you have a time to live. And depending on your use case, your time to live can be seconds or minutes or hours or whatever. So by combining those two orthogonal strategies, you can have a bounded cache. And if your time to live, for example, is very, very low, and your the number of entities is very high, your cache size is very high, perhaps you will never reach that limit. I mean, again, it's a trade-off. You must think what's the best in your use case.
Do you want to speak a little bit about I'm wondering about disaster recovery. I know it's a very big topic in banking, David. I've done part of it myself. What happens, if you lose, your data center for a certain moment? Like, how do you handle that?
Okay, here it's a bit more complex subject because it depends. You have different strategies. It depends on your business case. Often, to go on to add a bit more on what Nikola was saying. So we're talking about having data in memory, and the one thing that could definitely happen, and not only in a disaster losing the data center, but losing a machine. That happens much more than losing a total data center.
I was thinking about like a router or something like that, not the whole data center, but yeah. The equivalent, but a machine is a good example.
But so you lose your machine, and since your data is in RAM, as soon as you lose power, all the data is gone. And here you have different strategies you can put in place. Often you can say, okay, each time I put something in my cache, some mechanism puts it also in a data store. Data store could be a disk, a file, Cassandra, with Oracle, things like that. So there's always, when you do a put in the cache, it's already put in the database. And here you have already on this thing, you have different ways to achieve that. You could do that synchronously. So when you do a put, when you use your API put, you do a put, you don't get out of this put until everything is done down to the database. So you have a response from the database saying, transaction is fine, you've put the data in the data store. Or you could say, do it asynchronously. So you do a put in the cache, and you get you return back the control to the code, and that can continue. And in the background, here there's, I don't know, a buffer or something like that, and it's done asynchronously, and the data is put in the data store, whatever data store you choose. And also, when you have your cache is full, you can say overflow to disk or put everything that is too much, put it somewhere in the data store. And here we already see two things. I mean, if you do a put and you have to go to the database, when you do the put, you kind of lose the advantages of being all in memory because you still have to do an insert in a database or save in a file. But if you do that asynchronously, you keep it. But somehow, if between the time that you do your put and the put is put in a database, so the buffer is, let's say they decide to use to flush the buffer every 10 requests, every 10 put or something like that. If the application breaks down between the buffer is put, you lose your data. So again, you have to choose, do you want consistency, but then it's much slower, or availability? So the thing with in-memory data grid, they don't force you on choose one or the other, but it's a bit different. So it's you still have to think a bit differently. And if you want consistency, then you will still put in a database. But then when you want to get the data, then there's also different ways to see it. For instance, you do a get, and here you have different choices. Whether it's in memory, it's already there, fine, or it's not there. And then you have here possibility to say, okay, if it's not in my memory, go fetch it in the database, because maybe it's in database. So what's going to happen is going to go fetch it in the database, put it in the cache, and then the next get will get it, unless it's flushed out because of time to live and so on.
Okay.
So here you have a lot of mechanism to be able to save your data, to make sure that the data you have in RAM doesn't go away, and you have synchronization between your data in RAM and some storage. Then when it comes to disaster, here it can be very complex, because when you have a cluster of nodes which is spanning 2 data centers, it can be very complex to handle, because you will get into a split brain scenario, and then here it can be pretty fun. So I'm not going to go much further on this subject, because we could speak 1 hour on split brain scenarios and how to handle that. Do you want a stretch cluster on the data centers or not? But indeed, it's something you also have to think about. Yes.
Okay, thanks, David. I think we talked a lot about what Datagrids can do, what in-memory Datagrids can do. We touched also some of the limitations of Datagrids. So we touched about the difficulty of doing proper modelization, like the fact that the problem becomes harder all of a sudden. We also talked about the paradigm shift. What about the cost? Because I'm a simple person. I'm thinking memory, lots of memory, very expensive. Is an in-memory data grid an expensive thing to keep alive?
I think not. As I mentioned earlier, I think that the hardware itself is pretty cheap right now, and it's going to be cheaper and cheaper. But it's not free, because you add one more moving piece to your architecture. So the cost is complexity. And yes, as David emphasized a lot, then you need to take hard decisions. So you need skilled people to understand what are the requirements and how do we handle them. Now this is about the costs. I don't remember. I wanted to, at some point I checked. I heard that Amazon did a study perhaps 10 years ago where they measured the cost of latency regarding their e-commerce. And something like 1/10 of a second of lagging in a response had like a definitive impact on the revenue. I don't remember the study, I don't remember the numbers, but something that for me and you are not perceptible, like 1/10 of the second, they impact revenue visibly. So again, we go back to trade-off. How much costs RAM and what benefits does it give you? I cannot answer for you. You should be the one doing that computation in your own context.
No, I can totally
Again,
understand what you're saying.
The cost probably won't be in the hardware. It will be in the management of the complexity at all levels. And then what benefits does it give you? If you are a metrics-driven company, this is very easy for you to compute.
That's an interesting point, Nikola. That you have to know what you're losing already to be able to know. So it really, you have to be a little data-driven in the first place, I believe. Yeah, it's interesting. I know that
always.
in front end, for example, it's really a recurring thing. Like time to first interaction is extremely important. So, and as a customer, I see it myself. If I have to wait more than 2-3 seconds, I just change website. That's it. Probably never to come again.
Exactly.
Okay. Is there any drawback that we didn't touch yet or that you want to come back to? I think you mentioned really quickly, Nikola, the fact that there's no standard. It does surprise me a little bit. Is that because the technology is new? Is that because it's too complex?
That's a good question. I cannot tell you why it is so, but for sure it is so. So I know there is an Apache project that tries to not be a standard, but to be an abstraction layer, like it's called Apache Beam. It tries to be an abstraction layer over several in-memory data grids, including Hazelcast. But the problem, since it was done afterwards, then of course it's a very leaky abstraction. And so it's not that good in that regard. So I'm afraid that in this area, you still are subject to vendor lock-in. So once you choose a vendor, probably you will keep it for a long time, because migrating all your information system toward another one might have like very heavy costs associated with that migration.
Do you have more experience with this, David? You've been choosing yourself, I believe.
Yeah. So indeed, there's a vendor lock, and it never came to our mind. Not because the solution was good enough, but it never came to our mind. Should we change vendor? Because then you would really have to rewrite pretty much a huge part of your application. Even if you try to be, I would say, try to have a nice design where you have a multi-tier application and everything around the data store is well separated. It's still quite complex to change vendor. So that's one thing which is important to keep in mind. And it reminds me of this XKCD comic where you have two people saying, "Oh, we have, I don't know, 13 standards. We should create a standard to define them all." And then you have like, "Oh, now we have 14 standards." So that's why here, I think whether you start with a standard like SQL did, and then you have standard that people implement according to the standard, but you don't put a standard on top of something which is existing. And I don't expect this coming anytime soon.
It's actually my favorite comic, this one. I'll put it in the description of the podcast. I love it so much. You can use it in so many contexts. Yeah. Okay, I understand. All right, so we talked a lot about memory Datagrids at an abstract level. I want to get started tonight. I want to try myself. I want to create something. Where do you recommend starting? And I'm guessing where you're going to lead us, Nikola, right now. I know Hazelcast has an open source tier, right? Everything is open source?
Everything is open source, and on top of that, we have an enterprise offering, which with like security and the normal stuff you expect from enterprise grade solutions. But by default, all the nice features are completely free and open source, Apache 2 license.
Okay. So should I want to try something out from scratch? Is my computer enough? Can I set up a data grid myself? Yeah.
Of course. We have Docker images. We have Helm charts. If you like neither of them, you can download the zip. If you're in the Java space, it's very easy. Then you can use Hazelcast as a library. So you just put it on the class path. And then you can start Hazelcast instance on each instance of your app. And by default, they will multicast on the same network. They will find themselves. They will create a cluster by themselves. We are also not only providing you with Java integration, but we also have a model. That's the basics when you want to start, but we have a model where we have client servers. So basically, you have on one side, you have your Hazelcast cluster with how many nodes, and you can still scale them independently. And on the other side, you have your apps nodes, and you can scale them independently. But if you just want to start, just add it to your class path. You can find it in Maven. Just add it to the class path. We have Spring integration, Spring Boot integration. We are a Gcache implementation. As I mentioned, we have a second level Hibernate cache implementation. It's just a matter of
whatever you want. It's here for you.
I think that in the Java space, we have a lot of integration points, actually. I didn't mention Spring Cache also.
Is it joining on Java 14?
Sorry, again?
Is it Java 14 compatible?
Unfortunately, you know that a lot of customers, when they are Java 8, we are super happy. So we require Java 8 and plus at the moment.
I think you have most experience with other tools, David. Do you want to name them? Is that just for the sake of having another option, or?
Sure. So I work for ING, and in ING we use Ignite, and it has pretty much the same functionalities that Nikola described. The Spring integration, it's a Spring Bean. The configuration of Ignite is a Spring Bean. So if you're comfortable with Spring, you're comfortable. It's going to be easy to start your own cluster, and you have the same ideas where you have a set of machines that are your server nodes, and you start a client node that's going to connect to the cluster. And so, if you want to start first, I'd say read tutorials about Hazelcast, about Ignite. Go for some small tutorials, but I always find them very simple. It's like, okay, now you have your first cache, and you put data in your cache. Yeah, you're happy. I like to go a bit further. So what I like to do when I try a new technology is mostly think about a use case, try to understand a use case. And here we provide the idea of having the notion of fraud check. So a fraud check would say, okay, I have a customer that has an account. On this account, you have a set of transactions. Let's say I wired 50 euros to this person, I bought this from a shop, and so on and so forth. And what you want to do is when you have a new transaction coming in your system, check, okay, does this make sense? So you could check the amount, for instance. So here you would have to be able to access all the transactions for a customer to check the amount. So this is an idea to say, okay, give you an idea of what you could try to implement, where you could start already asking questions. How do you modelize your data? How do you modelize your customer? How do you modelize your account, your transactions?
And I'm guessing,
so on and so forth. And that for me helps me to put the hands like a bit deeper in the.
I'm guessing fraud check comes back, and I'm just figuring it out here, because if you want to buy something right now in the store, it has to come back very fast, right? You don't want to have to wait to know if the transaction is legit or not for 10 seconds at the counter. That makes sense. Okay. Thanks. Yeah, it's perfect. I really like to focus on use cases as well, because otherwise, you have your cache set up and then you're like, and then what? And you don't know how to use it. And yeah, it's good to have an idea in mind on how or what you want to do with it. Okay, thanks. We'll put the links in the description anyways, but Hazelcast and is Apache Ignite, right? Yeah, Apache Ignite
yes.
are the two tools that you could start with. There's many more, I believe.
Yes.
Right? Okay. We don't have to name them.
I mean, there are some in the cloud. So if you are already locked in with a cloud vendor, you can use the one from your cloud vendor. And then there is this Apache Beam abstraction. So yeah, there are a couple.
All right, thanks. I think that's enough. We're gonna go down to the conclusion now. We talked a lot about in-memory data grids. I think I do have a pretty good idea of what it looks like now. So we talked about the fact that it was very useful in case you want speed overall. We also talked about, the typical problems of distributed systems, right? CAP Theorem, split brain problems in case of disasters. That it doesn't have to be that expensive. I'm curious. I'm going to go and look a little more about that. If there's something specific about data grids and how it helped, with sales, I'm curious. Do you want to? How should we conclude? What do you think is a good conclusion? Famous last words from both of you. Do you want to start, Nikola?
Yeah, I was about to think. In-memory data grids are mostly used for caching, like for caching data, for making data available, regardless of the condition. A lot of people think about caching as being a very corner case, that you always need the latest data, whatever the case it is. And when you start scratching the surface, like questioning the business or asking the people, you realize that in most cases it's not the case. So I have two examples of that. The one is your bank account. When you check your bank, like legacy bank, your bank account, it's the cache from yesterday. You don't have the latest data.
And it's okay, right?
I mean, probably you would like to have the latest data, but as it is now, it's enough. It's good enough. And the second example that I like to mention is I've worked in eCommerce and imagine a microservice architecture of an e-commerce shop where you have the catalog service, where you have the checkout service, where you have the payment service, where you have pricing service. And of course, we want every one of them to be fault tolerant. And for example, the pricing, we should think whether we should cache the price. And most people, most developers, including myself, when we don't know about e-commerce, we say, no, we don't want to cache the price. We want the good price, the right price. But when you ask the business, and it comes back to the speed of the answer that I mentioned before regarding Amazon, they don't care that much whether the price might be overpriced by 10% or underpriced by 10%, because at the end of the day, everything will be average. What they want is to sell regardless. And so caching the price until the pricing microservice comes back to life is perfectly fine. And those are the two most useful examples that I have, the one that I can think of, but everybody in his own domain area can think of other use cases where actually you think you would need the latest data, but you can probably do without because there are other requirements that are much more important.
Thank you. I really like the e-commerce example for me because I always think about, if you make your customer unhappy once or twice, then you're actually losing the whole customer. So the actual loss might be huge compared to what it would be to pay 10% more for something. Okay, thanks. David, it's your moment. Chip in.
First, I'll try to just come back on the freshness of the data of your bank account. Sorry, but here we want to provide really the latest data. I know that, for instance, many times when I go shopping and I see that I don't have enough on my account to do the payment, I want to be able to do a transaction so that I have enough to do the payment. So here, no, we don't provide data from the day before. We provide very accurate data.
ING.
At ING definitely, but I'm sure that in every bank this is a minimum requirement. Okay, but
not in France.
Okay. Yeah. So, but indeed, for e-commerce, I would say for me a simple use case is also the stock. When you want to order something, it's okay that the thing is actually out of stock because too many people have ordered it. Because you can say, okay, we'll deliver a tiny bit later until we refurbish as stock. So for me, that's more like, okay, the stock doesn't have to be perfect. It's just that, we have an idea of how much we have left in the stock. So that's the eventual consistency that definitely as a customer, I'm really
okay.
But in the end, on our side, in the banking industry, it's all about what the business wants and what they are ready to lose or gain. It's always a matter of what you lose against what you gain. And here, you're ready to lose a bit of, let's say, if you underprice your item, to lose a bit of money compared to having a happy customer or not. And it's not a magic solution. It's not a magic bullet. It's not a silver bullet. It won't solve your problem. It will solve a set of problems. It will help you in different cases, but it's like everything. There's no one single solution that will solve all the problems. So don't take it as, because I have in-memory data grid, my application is going to be fast. No. If your business model needs like total 100% or let's say 110% consistency, you're not going to gain so much from it, because if you have to go to the database all the time, you won't gain so much from it. So again, it's a nice paradigm. It's very interesting. And also it's a new way of thinking how you modelize your data, but use it with pincets, use it with care, because it's not going to simply solve your problem from one line to the other.
Just like Agile or microservices or anything, it's not the silver bullet.
Like anything.
It brings you, it's one more tool around your tool belt. And yes, it comes with solutions and brings you new problems to think about.
Yeah, thank you both. Thank you for letting me invade your house for an hour. Like we've had it's not the easiest setup to work with. I really appreciate it. All right, that was another episode of Julien's Tech Bites. Thank you very much and see you next month.
See you. Bye.
Yeah, see you. Bye-bye.